Okay, right. So let's begin. Where was I? Right, connect forward. That's what I did as of last time. Yeah, commits. Let me just refresh what I did last time. I know I was kind of almost done, but I was kind of I had to like kind of cut it a bit short. Like I'm just wrapping up the stuff I was basically doing last time, just going to see it through the end. So this might be a short one. All right, so in drawer, I'm just like, yeah, so like in drawer, all that's left to do is to actually like draw the game state. But like I felt like kind of logging it here just so that like I could verify that like when we were actually applying like in game state, when we were actually applying the move, I just wanted to like add a console dot like print statement here just to like verify that the move was actually being like applied. But then obviously we're gonna uncomment this line and actually like draw it. So like that could be like the first order of business. And then what did I do here last time? Move buttons node, create human. So I dynamically generated like these buttons column 1 through 7 dynamically, not just like, yeah, I like first they were just like temporary just to like do the flexbox styling stuff, but now it's like they actually are binded to actually like drop the chip for the human, of course. What else? Start game. Oh yeah, start game. Yes, I remember thinking that like right now, like if we go first, then like we can kind of like play a game like with the bot. But like if we were to go second, everything is disabled. So I think that like we have to also fix that. Transition to bot turn. Okay, so we can actually call this. Yeah, let's just call this function. Transition to bot turn. And transition to human turn means that we just like disable everything. Okay, yeah. Okay, so let me first fix this issue where like these are all disabled in the beginning. And to do that, if they click go second, right? That means it sets that like, what do you call that? There's like a boolean here. What's the exact name of it? Yes, IMP1. Like if they click go second button, that's false, right? So then right here, what I could do actually after like is in start game, like if this is false, we can just transition to the bot turn. Yeah, let's just write that down. Okay, ls, reverse search for whim. Okay, what's the boolean? Oh wait, this is game state. Sorry, I need to do a game.ts. Game.ts. Okay, so the boolean is imp1. So then in start game, we create the buttons, we do the styling, and then we draw. Okay, so then I'm not sure like it really matters exactly where we keep this line of code, but let's do this. Like if I'm not player 1, that means like I is the perspective of the human player, right? Wait, how did I delete that? What the hell? Okay, so then if I'm not player 1, that means I'm player 2. That means I clicked the go second button, so this is false. So this whole if statement becomes true, right? Then what? Then what we want to do is we want to transition to bot turn, right? Oops. Oh yeah. So let's copy that here, paste that, indent the whole thing, and transition to bot turn. Wait, no, what am I doing? Sorry, transition to human turn, not transition to bot turn. Transition to human turn. Transition to human turn. Right, because like line 79 right here, transition to human turn, it just kind of sets these auto-enabled. Wait, no, it is transition to bot turn because bot turn calls human turn after making the move. Sorry, I don't know what I was thinking. Okay, so let's just undo that. Okay, this looks good. Let's right quit that. We saved it. Git status, git diff. Let's just quickly review our changes. In start game, if it's not, so like if we're going second, that means we're not player 1. Then we just let the bot do its business, do its thing, and then we just we continue. So now that's done. Let's add that. That looks good. The diff looked good. Now let's actually like finish the drawer stuff we were working on, right? The final line right here. Let's delete this console dot and let's actually draw it. Okay, let's draw it. So then for I'm just gonna open up game state 2. Game state.ts. And let's just see how, like, in the start, let's just iterate everything. Let's just I want some iterations. I need some iterations, please. Okay, this is an iterating. This is like a nested I want some code that just iterates over all the cells for me, so I don't have to do it myself. Okay, something like that. So here, right? Here, what we do is so for the row and for the column, this dot cells. Okay, so then it's not this dot cells, but this dot game state dot cell. So now what we're working with, the drawer right now, it has the I and J. Like, let's say that like there's a coin right here, right? In this 0, 1, 2, 3, 4, 5. Wait, what? 0, 1, 2, 3, 4, 5. Wait, 0, 1, 2, 3, 4, 5, 6. Yeah, 6 rows, 1, 2, 3, 4, 5, 6, and 7 columns, 1, 2, 3, 4, 5, 6, 7. Yes, that is correct. But okay, so in 0, 1, 2, 3, 4, 5, and then this would be the fifth row, and then the first column. I guess these numbers are off by 1 because of 1 in indexing. But anyway, so then let's just so this cell right here, its R for row index would be 5, 0, 1, 2, 3, 4, 5, and its column index would be 1, like 0, 1. So we have R equals to 5, and then C equals to 1. So then we have to draw a circle there. Okay, let's just like draw a circle based on the color. Okay, HTML, canvas, draw circle. This is actually a lot like BumperCoins, the drawing methods. Draw filled circle. Drawing a full circle, perfect. Okay, so then I think fill style, let's just select the color, right? Okay, arc is given by an x coordinate of 100, a y coordinate of 75, and a radius of 50. Okay, and then right, okay, yeah, that sounds good. Let's copy that. Let's paste it here. And then if the cell equals cell.waken, we just skip it. We just continue. We just forget that cell. That looks good. And then here, how do you do substitute in Vim again? Like print s ctx to this dot context, and let's make it confirm us. Yes, yes, yes. Perfect. Okay. Context dot stroke circle. Okay, yeah, fill. If I is greater than 1, context.fill. Okay, so I think we would do context.fill, right? Not stroke. Fill. Okay, that looks good. Now then, how do you specify the color, right? I think it's like fill style, right? I think I have this somewhere here. Yeah, Alice blue, right? Perfect. Line 21, GG, YY. Yeah, GG just means like a navigation command in Vim. Okay, so let's kind of go back down here. And then, yeah, we have to do a switch statement here, right? Because like we don't know the fill style. So then, like it's a ternary expression, like depending on cell, right? It's like cell equals to cell dot, what was it called? What were the enum categories again? Cell status dot p1 owned. Okay, so the cell status dot p1 owned. Else, okay, so now the question is like, what do we do, right? Like, what's the actual color? Let's add some static. Let's add some static stuff right there. Maybe like here. Static p1 coin color, just like I do in BumperCoins, and then equals to red, and then I think I already mentioned this later. We'll just have like the red start and then blue be player 2. Blue. Okay, so p1 coin color, just yank that. So then here, right, if it's this, then we do p1 coin color. Else, what we do is a p2 coin color. Oh, we need a question mark here, right? So if the cell equals that, like actually this equals, double equals, and this one kind of confused me. So let's just kind of be crystal clear about like the fact that like this is wrapped in a parenthesis, so that I don't kind of confuse this and that. Like, it makes it more clear to me. Oh wait, no, this is a static variable. We have to like do like drawer dot and then right there, right? Something like that. Okay, let's save this. And then now the question is what do we replace this x with, right? Same thing we did here, right? This dot scale factor times I, something like that, maybe. Instead of I, it'll be R times R. And then now, is there any off by 1 errors? Make that C. Okay, so then if R and C are, what was it, 5 and 1? 0, 1, 2, 3, 4, 5, and 1. Then the center point here for the circle would be what? Like 100, 200, 300, 400, 500. 0.5. So like, so okay, let's just say it's 0, 0. Let's just say it's 0, 0, 0. That's just the easiest. 0, 0 is the case where so then this thing would be zeroed out. So it's just this dot scale factor times R plus the radius, right? Okay. So this dot scale factor times R plus the radius we can like do as like this thing divided by 2. Or we can just like kind of add it to the R itself, right? Yeah, here's what I mean. This dot scale factor times and then like R plus 0.5. And then kind of same thing there. Oh, this kind of looks ugly. I don't like the way that looks. I mean, we could wrap it there, but instead what we can do is like we can just this dot scale. Oops. Let's just like kind of let's kind of just go here and do coin radius number equals to this dot scale factor divided by 2, right? So then here we would just do the scale factor times R plus the radius, and then same thing there. Wait, sorry, not coin radius, right? This dot coin radius, namely this dot coin radius, and same thing for the other one. Okay, let's check. So if it's 0, 0, like the top left one, then that would be 0. We just have the radius comma radius, which is correct, like radius raised to the center. Oh wait, no, this 50. Well, wow, 50 happens to be correct. Because 100 divided by 2 is 50. No, what are the odds? Right? A radius of 50. That's actually the radius we want, but instead of 50, obviously, we want to make it this .coin radius. Okay, so this looks correct to me. Let me just double check this for our 5-1 case, right? 0, 1, 2, 3, 4, 5, and then 0, 1. So then here, the center of this, according to our formula, would be a scale factor 100 times the R is 500 plus 50, 550. So like 100, 200, 300, 400, 500, 550, 550. And then so like we got the this row coordinate correct because that's the row coordinate for the center. It is 550. And then this one's clearly 150 by inspection. And then we know that C is 1. So it's 100 plus 50. So that's correct. Okay, this looks good. Yeah, let's just save that and then get status. Let's double check that everything compiles. Yeah, sorry, we have a run.sh script. Cannot find names. Oh yes, that's because we have to import it, right? Let's open that again. Import cell, right? Something like that. Did we export it? Okay, let's just export both of these, or let's export that. Yeah, let's export both of these for use elsewhere. Now let's try running it. Good, it worked. Status. Let's just add everything right now. Get status. Okay. Now for the moment of truth. We refresh. We go second. The bot placed it here. Well, it should have fallen, so we know there's a bug already. We'll drop it here, and then what is going on? Okay, this is really buggy. Yeah, this is terrible. Go first. What is going on? Okay, I'm going to print out the statement. I'm going to print this out because this does not look correct to me. What is this nonsense? .47 GG console.log this game state, compile everything, go first, place it right here. What? Oh, it's like a transposition. Like, is the R and the C reversed or something? Oh, could it be transposition? Because, like, here meant here, there, right? Okay. Yes. That explains it. I feel like this language, I mean, maybe I'm just like, so then this should be C and that should be R, maybe, but let's just double check. This got me earlier. X coordinate, Y coordinate. Yeah, so the X coordinate is actually the column index and the Y coordinate is a row index. We just swap the R and the C's. A simple transposition. RR, okay. The stupid leaf blower. Let me make sure that my window's closed. I don't want to breathe that nonsense. Status. Let's make sure this compiles. Let's add that. Okay, now let's try it. Go first. Okay, I go first. He goes there. Sure, I'll go here. He goes here. I'll go here. Did I just win? I won. Okay. So now we need like a console.log statement, which like tells me that I won. I'm gonna introduce a bug where like I'm gonna also see the bug where we filled everything up. Fill. And he tried applying the move. Illegal move. Should not see message illegal move. Okay, good. Good. So now I guess I placed it here and the bot tried to make an illegal move. Okay, so we should put that under consideration. Like we should kind of stop this message from showing up. But more importantly, like before that, we should let's actually like create like the case where we like some logic to detect that we have like done this, like we've kind of found out connect for, right? We actually wrote the game logic for that. Like this is the very first function we wrote in game state. Okay, so where do we kind of sync that logic in? First, let me just commit this because finish drawer status get push. Okay. So now what? This is a good save point. In fact, I could just stop right here. No, I feel like I should. I'm not really in the mood to do stuff. I'll just look at it, see if it's easy enough, I'll do it. Okay. It's a bot turn. So right here, before transitioning to the bot turn, we should check if we won, and then somewhere similar to there. Okay, so I mean, there's clearly better ways of organizing this. Like right now I'm doing it like bottom up, ground up instead of top down. So like, I mean, it's a small enough, simple enough game that I can just kind of have this spaghetti code here, but yeah, I'll just have the spaghetti code here. So then like some like function that like, yeah, I think, let me just quit this, game state, ts, right? So like, right here we have like a get game status, right? So like, wait, let me make sure that we we export the game status. Actually, let's first do that. Let's first copy this and then kind of get the game status, right? This one, enum game status. Game status. So then now, now that we applied the move, then if game status dot game state dot, what was it called, the function again? Let me just copy that. Dot get game status. Equals to game status dot ongoing. We just continue, obviously. Actually, let's extract this code in some like other function. Let check game over equals to function, and whatever stuff that was being done here, we'll just kind of place that there. And then here instead, what we're gonna do after we apply the move, whenever we apply the move, what we'll do is we will just do a check over. In fact, I could kind of like create our own apply move function that kind of wraps these two together. Yeah, let's do that. Let apply move. it should take in like the Boolean, right? For human Boolean, maybe for me or new move. Like here we have apply move. Let's just search for apply move. This one here, that well, and this one here, dummy bot move. Actually, no, let's just take in the move itself. Move. Apply move. Just take in the move, and then what we'll do here is we'll just kind of do the game state dot apply move. Dot apply move. Move. And then what we'll do here is like whatever this check.gamestate, like this whole thing here, what we can do is we can delete that. Dot ongoing. And we just return out of it. There's nothing to be done. Oh yeah, we can do this in like a switch statement. Switch TypeScript switch enum. What? It doesn't work? Okay, yeah, okay, so switch, and then, yeah, same as Java, I think. So then switch, game state dot that, right, so then case. Case that. Let's just take this. Take all the game state cases. Okay. Just return that. Okay. So then if it's ongoing, then there's nothing to be done. We just do nothing. So if it's player 1, then what? Player 2, draw. Okay. Yeah, let's just like log a message, right? Like, that's like having some outcome string, right? Like, yeah, actually we have that, right? Don't we have that in like a prompt actually? Let's add that. Game.html, right? Game.html. Yeah, we actually have a prompt. We have to like we have to like kind of give a message in prompt, right? Yeah, let's do that. Like inner text or inner I think inner text. Yeah, let's just first define this right here, right? Like let prompt, let game prompt or just prompt, yeah. Game, yeah, prompt. I should use Wim's code, not just like 4 deletions. Prompt HTML something like this, equals to that, right? So this is prompt. Okay, so here's prompt, and then where was I? Apply move. Prompt dot inner text equals to game outcome message. Let's define this right here as a string. Equals that. Then equals, let's say, player 1 1. Oh wait, no, not player 1. U1 if you're human. Game winner, player 1. So then, like, the game winner, like, game winner could be human or bot, right? Plus one. What's a draw? Let's kind of bring that there again. Game outcome message. Yeah, let's just do this. So game outcome message is like, what's that called? Like, what's the Boolean called in the beginning? We're in line 56. Let's save that. IMP1, right? So 55 GG. CZ to center it. So if I am player 1, that means like I won. That means like, so then that means the human who's playing this is player 1, and player 1 won. Then like you won. Game over plus the message, space plus the message. You won. And then, or else, that means I'm not player 1, but player 1 won. The bot won. And this will probably be the same exact thing here, except let's kind of do that, right? So like invert it. So then, like here, if it's player 2 and I'm not player 2, yeah, exactly. Yeah, I mean this should be clear. And this one here, right, is the game ended in a draw. And then prompt.inner text. Wait, what? Dynamically set piece paragraph content. Did I change text? Yeah, sure. Inner HTML, correct. Okay, wait, no, inner HTML is not like some, is this a security thing? Inner text. Well, it's. I mean, this is like a static page, so I don't think it matters. Inner text. Yeah, so something like that. I think inner text is like the way to go. Not that it matters, because like it's not like a chat where we're kind of like pasting some inner text that someone else gave us. It's pretty much hard coded. But anyways, I don't know. Let's just use inner text, right? So prompt.inner text equals game over, like that. And then we should disable everything again, right? We should disable all the buttons. Actually, what we could actually do simply is we could, well, yeah, we will disable all the buttons, and then but let's say that like right here we applied the move, a human move, right? Then like, and we did it right here, right? Like we apply the move instead of here. What we're gonna do in like line 40, I create a space here. Instead of that, what we're gonna do is call this apply move on this function here, right? But then the problem is that we apply the move, we draw, like we reflect it, but then like what if like the game ends when we transition to bot turns? Maybe we should return a boolean, right? Yeah, let's actually return a boolean, which is game over, right? Game over. So then let game over boolean equals to that. So then if the game is over, we do not want to transition to bot turn, we just return. Like we break out of this. So like if the game is over, let's just disable everything here. Right, we disabled all these buttons. So we disabled all those buttons and then we return game over. Now where do we actually set game over? Let's just set it here. Game over equals to false. And the other cases are true, so let's just have that by default be true. Game over boolean equals to true, and then if it's ongoing false or else like it'll remain true. And then we return it. So then here, if the human plays, then we just oh yeah, actually let's just take this draw thing right here, and let's actually kind of extract it and put it into apply move, right? We apply the move and then we draw it, like, cause like that everything's kind of like the whole idea behind this apply move helper function in line 50, like this whole thing about like this whole function here, just like a bit of a helper thing to couple in a bunch of stuff, as opposed to like whenever you call apply move, like you have to kind of draw it and you have to like check if the game is over. So let's just kind of bundle that together in our kind of apply move wrapper that wraps around this function. I mean, it's just like for syntax, I mean, just a bit of like convenience, as opposed to like writing those 3 lines grouped together in multiple different places. Let's just kind of consolidate that. Again, just some ergonomic, just some convenience things. Okay, so then here, let's look at this. So here, game over, right, is a boolean, we apply it, and then if the game's over, we just return. That means like we return so that we don't have to, like the whole point behind this return is to not transition to bot turn, because like the bot turn has no right, like the game's over, we don't need the bot to move. So we have used this new function here. Then what's the other call? I think I was like kind of searching for this here. Let's kind of reverse or apply move. So here we do that there, we define it, and then I think the bot has to do apply move too, right? Okay, that's another call right here, and then it wraps over. Okay, perfect. ZZ to center. Okay, so then here, instead of apply move, dummy bot move, let's kind of delete that, and apply bot move, right? And then like same thing here. Let game over boolean equals to apply dot move, something like that. I'm in line with 103. What did I do earlier? 40 GG. Yeah, just that. Oops, sorry about that. Yeah, paste. Right. So if the game is, oh no, wait, well, then we delete the draw.draw because we have kind of applied that into the apply move. So just look correct. Yeah, so then next step is to actually create a bot class, right? The bot class will like know if it's player 1 or not. It may have like its members would be like the bot, like we have a new file called bot.ts. We instantiate a bot object. I mean, sure, we could just have one method, but I think like it should be good to extract, because like when we like actually apply the neural network, like the bot's logic will be like to apply a move, like it would take the game state. So the bot needs to know like the boolean, like is it player 1, is it player 2, like it needs to know which player it is. That's how the game state would make sense to it, like in the context of whose player it is. And from that, it can like use that to build the like like it'll use a neural net, right? Like if it's player one, if it's the bot's turn to move, like its coins would be in the first two image planes, or else it would be in the first image plane, or else it'd be in the second image plane, right? Because I mentioned that in the previous video for like the input outputs in neural net, right? Like I only talk about the input and the output, like in BumperCoins and a bit of Connect 4. I didn't actually talk about the middle stuff because, to be honest, like there's so many different architectures to use, like a ResNet, like a recurrent neural network, or like a convolutional one. I'm going to use probably convolutional or just like a simple MLP, like just hidden layers, like no fanciness. But I think like convolutional, because like like image stuff, like we're dealing with image planes, so like I think using convolutions is like kind of like it's like kind of what you do. Yeah, I may have to like look into the math. I mean, look into like reasons behind that again. I remember like looking into that. But anyways, the whole point is that like we'll create a new bot class. The bot will know like its members will be like a boolean if like am I player one or player two for the bot, and then we could also pass in some future parameters like a difficulty level, like how many like levels deep do we have to like do the Monte Carlo search. Like the easiest one would just be like no search at all. Like we just like take the game state, look at the boolean, and from that we can like build the image planes to pass into our neural network, and then we can get a policy, and we can just argmax, right? We can just like choose the move with the highest probability and just like play that. And if I think that this like network, like for BumperCoins, I think like neural nets could take like maybe like 100 milliseconds, or I'm not sure. I remember like trying this a few years ago and like in a very crappy laptop, and like each call to like the neural network's prediction method would like take like 100 milliseconds. So like you can only like you can't really do tree search, Monte Carlo. You can't really do tree search and like kind of like look at your state. Like I do this, he does that, I do this, my opponent does that, and like so forth, and like kind of like branch out and like do a Monte Carlo tree search, or like maybe even alpha beta tree search. Like there's not really enough time to actually like do that. In Connect 4, maybe there could be enough time. So like we could actually go several levels deeper too, similar to how we train it. Like the training and the practice are often different, I believe. I mean, well, it depends on the game. Like I think in alpha, in the alpha go, and like in like the alpha 0 for chess, like when they're creating a move, like when they're actually like deciding what move to play in a live game against someone, or like yeah, in an actual game, like they actually do the Monte Carlo tree search at like some depth level. So like the bot can like take in the depth level, or like how many times we do Monte Carlo tree search. Like it's like the greater the number, like the deeper, like the more trajectories in the search tree that we do, and like the more refined, the more accurate our Q values our Q values would be. Actually, there's like two ways. I'm not sure. Like one way, like given a Monte Carlo tree search, like one strategy is to just like take the root and like look at all the children, and then take the one with the strongest like Q value, not the children, yeah, the strongest Q value, like which action gives me the best expected reward, and return that like argmax from the root based on all the action edges. So like all the Monte Carlo tree would be like a graph, right, where all the nodes are the game states and all the edges are the actions. So it's like the action, the edge, the action has a Q value associated with it. Like the Q value is like kind of like on the edge. It's not on the state. Like yes, the state has a value, right? But like we don't really care about like the state, like the state's value. That's like inherent in the edge leading to that state. And then that would be the Q value. Like S, A, S prime. We take action A from S to get S prime. So the Q value is tied to the edge A. And that's like a nice, like a little, that's just kind of like the, like we could put that value, that's just like the way that reinforcement learning tends to do things. Like they have Q values on these state action pairs. So anyways, where am I going with this? Yeah, I'm saying that like the bot class that we do, yeah, I'm going in a tangent, but the whole point is that like we'll be like right now we're just like randomly randomly sampling, like taking a move. We're not even checking if it's legal. If all the columns are full, we couldn't be doing an illegal move. Like we actually just saw that. So in the future, like we need to obviously like we could like just for groundwork, like what I'm gonna do is like just like do a random move. Like that could be fine for now, just to like show that visually the game works. Like we have a basic setup going. But like eventually the idea is to extract a new bot class, right? Like a bot.ts file. And like it could take in like it has to take in a boolean, like is it player one or player two? It has to take in the game state, right? So those are like two guaranteed. And then we might also add like a parameter, like some depth parameter or some number of like how deep we search to refine, like kind of like a difficulty level, like maybe even like a toggle for the user to choose. I believe in like the the alpha 0 for chess, like when they they actually did the like sorry, I have to backtrack. I didn't actually finish my thought earlier. When I said like there are two strategies in Monte Carlo tree search, I think like I'm not sure which one's used. One option is to look at the Q values from the state, and I kind of went on a tangent on what Q values mean, how they're the edges in the graph, the tree. But like that's one strategy, like look at the actual Q values, and the other one is I think like look at like which state was reached the most, like kind of how we build the policy. Like we kind of like in the that really brilliant, like the really kind of simple, like very kind of nice example, like when we actually get the policy, right here, the improved stochastic policy, this policy is simply the normalized counts, like this, right? So like it's a question of how frequently the node was visited, and the concept, like the idea behind that is like whichever node gets visited the most means that's like the best kind of path we should take, and like that's kind of, yeah, it's like, yeah, ns is like the number of times we took the action A from state S. So it's kind of like its own Q value, sort of. It's like similar to like a Q value, right? Like, so NFSA is the number of times that we took A from state S across simulation. So like if you look at like the sum of B or NF SB, then this thing, like if you think about it, like the number of times, like every time we visit a state, like we take some action route, right? Like that's kind of how it works. So in a sense, like this whole thing when you're summing over that could be viewed as a square root of the sum of how many times S's parents, wait, is it, sorry, yes, so like if we do this, like this whole sum basically kind of becomes like how many times the node S was visited, I think, right? Because like from S we can take several actions, like we're summing over all the actions in B, and like we're kind of looking at this one, but like the whole point is that like this one kind of like gives you like just like how many times like we took S, so like let's say that if you take action A from S, we get S prime, right? So the NFSA is basically how many times S prime is visited. And if we're summing here, then like this is basically kind of how much S prime has visited the child. And then this one is like the numerator inside the square root is how many times S was visited, and that's how many times the child was visited. So like that's kind of like another interpretation, like what the sums mean. Because like whenever you visit some node, like and you have children, you just propagate like to all of them. So like the sum of like, anyways, the point is that basically like there's like two ways. Like one is like look at like one idea is like looking at the normalized, like choose the node like from the root, like there's some actions, then we can look at those like child nodes and like look at the edges, like the Q values, and like say, hey, like which one gives you the best Q score, the Q value for the state action pair, and the other one is like for the state action pair, like how many times was it visited, and like use the ones that visited the most. So like those are two strategies. I'm actually not sure which one they do. I think that they actually like get the stochastic policy, and then again they just like sample a move from it, like in training. Like that's how training, but in practice I don't think they actually sample the move. I think they just do an argmax and like choose the move that was like kind of the edge that was visited the most, and they take that. Or you can take the Q score. I don't exactly remember how they did it. And they actually had a really nice comment, like some table where they showed like that the bot, if you completely like if you train the neural network that they did, and then you like kind of like, and then you play with that and you don't do any research, you simply use that, so like depth was 0 or 1, and I think depth 0, like you just like pure instinct, like you just train the node, like the neural network, and then like you query the network for like the move to make, and you just play that move. I think like its ELO was, I can't remember the exact ELO, it was like maybe like 2500. It was like kind of like a maybe strong IM, weak GM level, or like it was definitely maybe even like a strong GM level. Like it was very competitive, even without doing tree search. The neural network itself, like you gave it the game state, it'll spit out a move, like a policy, and then you choose like the best one from it, and you just play that. You just argmax or like the P, which it returns, right? P theta, right? Like, yeah, it just returns a policy, and like even if you choose that one, Like you just like argmax and like choose like the best policy that like, or all pass, like choose the action that gives you the best like highest probability. You just play that. Like it went a bot like AlphaZero bot like for chess for like that they did like was exceptionally strong. So I think in my game BumperCoins, I'll just like literally just like kind of take the net, like how the bot would work, bot.ts and BumperCoins, it would just like compute the policy and just choose the action with the highest probability and just always play argmax that. Whereas like for Connect 4, we might actually like do a bit of like Monte Carlo tree search to actually get an improved policy. So like we could actually do that too, both in training and in practice. That's why the bot TS could have some like parameter that like allows us to like kind of control how deep we go. So it's kind of a proxy for how strong the bot is, and maybe the player could choose it. Anyways, that's just explaining how we actually resolve the to-do. Right now we're just doing the groundwork for this stream. So then yeah, so then dummy bot move. So sorry, I talked a lot. Am I done? Yeah, like to-do. These to-dos are kind of like similar. To-do, for now, just random later extract onto a bot.ts file. Okay, so does this look good? I'm kind of lost because I was going in a tangent. I kind of forgot where I was in the context of this file. Let's just save it. I mean, let's just actually see if it, let's just test it out. I don't remember what I did. Okay, error. Line 116. Wait, what? Line 116 game.cs expected. Apply move. So is there like some like mismatch like parentheses? 116 line 50. Okay, so the question's like line 76 paren. Okay, so the switch statement, yeah, I forgot to do that, right? So now if you look at this one, yes, it like I go 50, 77, like we kind of like do like shift percent to like kind of do that. Okay, that should work. Was missing a close paren? Cannot find game status. Oh yes, because it's game state. Let's fix that. Okay, now let's try running it. Just clear it. Too many errors. What? It's a Boolean. Okay, line 50. Yeah, Boolean, that means game over. Turns true if and only if game is over. Okay, now let's try running that. $40. Wait, what? Oh, no, it's a function that returns a Boolean, right? Child buttons. Cannot find it. Okay, let me just use the restroom real quick. Alright. Hang on, let me drink some water. Okay, right. So 2 errors. Line 72, 73, child buttons. What is child buttons? 2GG, CZ, child buttons. I mean, I do, okay. Okay, get status. Before I add it, let me just do a little diff. Actually, before doing that, I just want to like run it, see what actually see how it looks right now, like where we're at, right? See how our game looks. Go second. Bot moves. Okay, where do we want to move? Well, let's control the center. Bot goes there. I mean, yeah, let's just stop it. Okay, so he goes here. Okay, now I just want to win fast to check our game over code, right? Okay. Game over, you won. All these are disabled. Very nice. Very nice. Okay, now let's check diagonals. Right, okay, I could add a button to like refresh the game, or like rematch, like whatever like my game does, but for now refresh is not a big deal. I'll go first this time. Try to win diagonally. Wait, why is it playing strong? Okay, I won't win here on purpose because I want to like test my diagonal forward and backward diagonals. Or rows. Yep, I have a forced win now. Can you guys see it? I just go here. If he blocks, I win on top. And he doesn't have any counterplay. Like it'll take him several turns, like 1, 2, 3 to do something. But I have a forced win by moving 1 and then forced win in 1 or 2, like mate in 1 or 2. So I move here. Oh, I can win this way or this way. Should I try to humiliate my opponent and win 5 in a row? Yep, I can place here and win 5 in a row. Oh, in fact, I have to. It's forced, or else he'll win. So now I want to see... Wait, why is it game over? Wait, what? Why is it saying game over? It's not over. Wait, what? Game over, you won. Wait, well, let me refresh that. Wait, I place it here. It says game over? Wait, what? I know game stats are ongoing. Oh, that's why. That is why. Okay, wait, maybe. Game over. Let me search for game over. Oh, wait, how does it search for? Okay, fine. Game over. Right, so this thing is null. So, like, if the game is over, yeah, let's just migrate that inside here. Because it could be ongoing, only if it's over. Okay, perfect. Yes, that looks good. Get status, yeah. Okay, this is. I think else to get add. Actually, no, before I do that, let me just actually like look at the chain set. Okay, this thing irks me. There's an extra space here. Let's actually delete that. Let me just delete that. OCD. Wait, where was it again? Which line number? I thought it was 6. 15. 16. Prompt. 15, 16 line maybe? Let's delete that one right there. Okay, now let's do get diff. Let me just clear everything. Cubed. Just clear everything. Get diff. Okay, so then we import game status. We add the prompt to like say game over. Okay, and then apply move. Apply move. Oh, maybe the prompt should also like give messages for like it's your turn, it's your opponent's turn, or something like that. I mean, well, for now the columns are disabled, right? I mean, enabled, disabled. It's like that kind of tells you it's your turn. Yeah, there's no need to be too over-engineer this. I'm just having like a really quick and dirty connect four thing. Because again, my main goal is BumperCoins. Like I literally like, I could be super professional. I mean, I think being professional is good in a matter of principle, but I mean, I've already proven that I've built BumperCoins. I don't really need to like build like a enterprise connect 4. There's like an enterprise fib. What's it called? Foobar fib. Fib buzz, like some like funny GitHub repo for like some interview stuff. But anyways, okay, I hear leaf blowers again. I hate leaf blowers. They're so noisy and annoying. Maybe I should move to like a city where gas leaf blowers are banned. Electric only. Anyways, yeah, it's distracting me. So the point is, I'm looking at the chain set. So then I'm creating a reference to the prompt. I'm deleting the supply move in favor of a new helper wrapper function that wraps that and kind of wraps the drawer too and some other stuff. Returns a boolean, so like kind of checks J's down and like many command line stuff like vim terminal whatever less distiff. So get outcome. So then like apply move applies the move to wrapper. It draws. It checks the game outcome. If it's over, then we now we migrate that. So like if it's over, it'll say game over plus the outcome message. You won bot 1 game ended in draw. Too bad we can't really test drawn because the bot's not strong enough to hold me to a draw. Actually, could I like play bad and just play defensively and secure a draw? I do want to test everything. But anyways, okay, and then start game. What else? Just a bunch of comment changes, and then this one. If it's game over, then we do not transition to human turn. Just like earlier here, if the game's over, then we should return. Don't transition to bot turn. Okay, this actually looks really good. I'm just gonna add everything. Get status. Let's just test this one more. Let's just refresh this and try it one more time. Wait, just hello. I could probably uncomment. I like to see the hello. Yeah, go first. I'll go. Bot goes. I go. Bot goes. I go. Bot goes. I've checked horizontal. I've checked vertical. Now I should check forward diagonal. Let me try to win forward diagonal. Go here. Go here. If I don't be careful, he could actually kind of win. Yes, I could win here. Actually, could I like bait him into winning? Never mind. Okay. Yep, I can now win here. Wait, why is it game over? Oh, I forgot to compile. Right, I forgot to actually compile this. The JavaScript is not being compiled yet. TypeScript's not being compiled. Okay, now it should be compiled. That was a sober. Yeah, go first. I'll go here. For diagonal 10. Let me refresh. He made it hard for me. I'm gonna actually go here on purpose, just to like. I have to force him to go there, because if I go here, then I want to like make this. But then he might actually block me. I mean, I need him to block me. If I put here to kind of build it, I win. So I have to force him to do that. Oh, he did it. Okay, great. I mean, yeah. What if I put, okay, should I play defensive and I'll let the bot win, maybe. Nope, he did not. He could have. I risked it. Now I can finally win by testing this forward diagonal. Wait, what? It didn't say game over. It does not think it's over. I'll just game over horizontally. Game over, you won. It did not tell me that I had won, so there is a bug somewhere in the. Okay. So like this is wrong. I mean like the gamestate.ts get game status. Yeah, so then this forward and backward die scores, like something here is not like working correctly. Score forward R plus C. Yes, that is correct. So I'm putting if absent like a new empty thing. Score to die forward dot get score forward dot push cell. Oh. Okay. Let's I'm going to set a breakpoint to like see what's actually like why this did not work, right? Yes, here's game state. Get game status. Do forward. Okay, so somewhere right here, do forward, right? Here I need a breakpoint. I'll only turn it on when I'm about to win forward. So there's my breakpoint. Go first. It's hit. Okay, let me just disable it for now. Resume. I'll only turn it on when I'm about to win. Okay, let's turn it on. Here, right here, and then right there too, so I can inspect it. Okay, score to diag forward. What is this? Right. Is a map. Size 12 entries. Where are the entries? So what is the score? Like, you have to do I plus J. So like this score is like 0, 1, 2, 2, 0, 1, 2, 3, 4, 5. 2 slice 7. So the score for 7, right? Wait, what? Why does that have so many entries? How can this have 7 have... Wait, what? Sorry, wait. I'm so confused. Entries for score 7. Oh, the value is 5. Wait, how can I have 5? We only have 1, 2, 3, 4 as most. What? Oh, because it's the cells. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5 because of that, right? So the value is what? 0, 1, 1, 1, 1. Oh, because it's going from row order. It's like 0, 1, 1, 1, 1, right? So 0 means vacant and then 1, 1, 1, 1, right? That is correct. I found 4 in a row. Okay, let's step into it. Let's step into 294, right? Let's play that. 4 in a row checker of cell list. So what is cell list? Okay, so we have to do it for the score 0. We don't care about that. The cell list here 1. We want it to be 7. So score's 4. Okay. Score's 5. Score's 6. Score 7. So now cell list, right? 0, 1, 1, 1, 1. So now we want to step into this, right? How do we step into that? So here, cell list, right? Our cell list is 0, 1, 1, 1, 1. So okay, let's keep stepping. The cell is 0, means vacant has count 1. We found this one. But now we have found a new color here, right? So now the cell means cell 1 in the enum 1. Like again, this whole enum business is like a P1 owned, right? So P1 owned. Okay, we're doing it again. We extend the count, so now it's 2. It's not 4, so that if does not reach. Keep going. So now count is 4, is it not? It's 4. We found it, and the cell is not vacant. That is true, right? The cell is 1. So cell is P1 owned. Right? So we're going to return P1 1, correct? return res, which is 1. And again, 1 means it's not ongoing. Game status dot player 1, right? Oh, this return does not like only returns in the context of like I see the problem. So like this function here, right? Just kind of returns a res, but like we want to return from like the whole function, right? That's the issue. Okay, I see the problem. Yes, correct. Okay, so okay, well, let's fix that. Yes, that's a nice fix. Like right here, like you see like when I'm doing like this like return ongoing. Wait. Get game status 4-row checker. It returns a game status. Like this 4-row checker is 100% correct. I mean, I'm pretty sure it's correct. So when we're doing like return row, like right here, we're returning out of get game status. That's the whole point. And like same thing for our do columns. Like we're returning out of, like we're breaking out of this entire function get game status. Did I change anything? Okay, no, I didn't. Okay, 40, somewhere here, right? Okay. So then like do row, do call, but then like we're kind of breaking out of the entire thing, which is good. But then here what's happening is we're returning res. Yeah, so that's the problem. In fact, I don't like this for each. Can I like somehow like, I already talked about this earlier, use like the okay, fine. I hate to do this, but Boolean done equals false. Or actually no, Boolean, sorry, something like this. Basically, these reses will be based on that. And then like if the res is not equal to game state dot ongoing return res. So res is both like Boolean check on ongoing, like whether we're finished or not. Because ongoing is we haven't finished. It's non-terminal or not. And it's also like it also stores like the actual result. Again, this really I do not feel comfortable with this. I'd much rather like the return works, but I can look into that later. Actually, let me actually check that. TypeScript or JavaScript return in lambda return outside. JavaScript, not JavaScript. That was a Java answer. I forget it. I'll just go with this. Actually, for now, I'll just stop. Yeah, I'll finish the rest later.